When we solve AMC or other math competition questions, division problems often come across as a challenge. Let's take the 2016 AMC 8 problem 24 as an example. We see that PQR is divisible by 4, QRS divisible by 5, and RST divisible by 3. Given this information, I don't even know where to start, but not with the knowledge of divisibility rules. These rules help determine when positive integers are divisible by particular other integers. But it's important to note that these rules only apply for base 10. Other bases have their own different versions of these rules. And using these rules prevents the need for complicated calculations for determining divisibility. This can be useful especially when determining whether a large number is divisible by a given number. So let's get into it. First is the rule of 2. A number is divisible by 2 if the last digit is even. So that's 0, 2, 4, 6, or 8. For example, 128, the last digit is 8, so it's divisible by 2. Same as 64, the last digit is 4, which is divisible by 2. And a number is divisible by 2 to the nth power if the last n digit of a number are divisible by 2 to the nth power. So let's take 216 and 2 to the second power. So the exponent here is 2. So the two last digits of the number is 16. And 16 is indeed divisible by 2 to the second power, which is 4. So it is divisible by the 2 to the nth power. Now the rule of 3. A number is divisible by 3 if the sum of the digits is divisible by 3. For example, 381. If we add 3 and 8 and 1, that equals to 12, and 12 is indeed divisible by 3, so 381 is divisible by 3. The rule of 5. A number is divisible by 5 if the last digit is either a 0 or a 5. That will be quite easy, as you already all know. 20, the last digit is 0, 35, last digit is 5, so they are divisible by 5. And a number is divisible by 5 to the nth power if the last n digit of a number are divisible by 5 to the n. The same applies to the 2 to the nth power. So let's take 1350 and 5 to the second power. Exponent is 2, so the last two digits is 50. 50 is indeed divisible by 5 to the second power, so that works. The rule of 7. A number is divisible by 7 if the number you get after doubling the last digit and subtracting it from the number made by the other digit, the leftover digits, is divisible by 7. So this is a bit complicated. So listen closely to the example. The example is 105. So first we need to get the last digit. So last digit is 5. And then we need to get the number made by the other digit. So that's the number excluding the last digit, and that's 10. So if we double the last digit, that becomes 10. So 10 minus the number made by the other digits, that's also 10. 10 minus 10 is 0, so that is divisible by 7. So this number, 105, is indeed divisible by 7. Rule of 10. A number is divisible by 10 if the number ends in a 0. That'd be quite easy. 20, 30, 40 all ends in a 0 and is divisible by 10. And for powers of 10, if the number has the same amount of zeros as the exponent value, that works. For example, 123,000 and 10 to the third. Since there are 3 zeros in this number and the exponent is 3, this number is indeed divisible by 10 to the third power. And lastly, the divisibility rule of 11. A number is divisible by 11 if the alternating sum of the digits is divisible by 11. So what we mean by alternating is you first add the digit and you subtract the digit and you continue to do that. So for example here, there's the number 1364. You first add 1 minus 3 plus 6 minus 4, and that becomes 0. And that is divisible by 11, so this number is also divisible. Next, 3729 plus 3 minus 7 plus 2 minus 9, that equals -11, so that is also divisible. And the last example, +9 minus 8 plus 7 equals 8. So this is not divisible by 11. For more information and research regarding divisibility rules, I suggest you visit these two sites, and also it, it will be a lot of help if you watch detailed divisibility rules on YouTube, the explanations. So that's a wrap. Make sure to use these rules when solving AMC and other math competition problems because it will be really effective in your problem solving. Thank you.